Thank you for spending a little time with me today to get an overview of the COMTRADE utility for OSI Soft Pi. For those of you who don't know what COMTRADE is, it's a standard file format to capture very high-speed disturbances on the electric power system. We've all experienced these disturbances as power outages. These power outages are called transient disturbance events. Typically, they can be caused by lightning or other short circuits to the distribution or transmission system. When an outage occurs, however short, there are two types of questions that need to be answered. One regarding the protection of the electrical system, and then some business-oriented questions. There are some common questions between those two. What happened? Where did the outage occur? Did the protection operate as designed? Are there any changes in the design required? For businesses, though, there's two additional questions. What equipment and customers were impacted, and is this a recurring problem? If the answer to is this a recurring problem is yes, then obviously some type of systemic design change may be required, or condition-based maintenance may be needed earlier than was originally anticipated. This is a view of an actual disturbance captured within OSI Soft Pi using the COMTRADE utility. You can see it's very high fidelity information. The entire disturbance lasts less than 1.2 seconds, and the sampling rate of this information is about 20,000 samples a second. In reality, the COMTRADE file creates a triggered digital oscilloscope capture of the pre-configured information that could be related to an event that allows engineers to look at the data and determine actually what caused the event. Typically, the capture time frame is 3 cycles before the actual event and 7 cycles after the event was detected. Devices in the field actually capture this information in real time. The next problem is, how does a protection engineer know where and to which devices to go to actually retrieve the information? There are a couple of different ways that the protection engineer can be notified of where to look. In one case, a customer can call and say, I've had an outage. Utilities today also have customer information systems and outage management systems that can also be used to notify the protection engineer. In some cases, the energy management system and SCADA systems could potentially provide some type of information to allow the protection engineer to know where to look. However, the problem with EMS and SCADA systems is their sampling rate typically misses these transient events since they sample at 2 to 5 second intervals. The devices in the substation are actually the authoritative place to go get the transient disturbance information, and you can pull and look for new files labeled as discovery that let the protection engineer know that there's information that needs to be considered. Once the protection engineer knows that there's an event, they use a vendor-specific tool to go out and acquire the information from the actual devices that have the new disturbance information. They use a tool to actually analyze the information in the file. If the analysis indicates that there's systemic problems that need to be corrected, work orders or changes in settings are used to actually correct those problems. And instead of storing the file for future retrieval, typically most of the retrieved files are thrown away. This process needs improvement. The first area where it needs improvement is the time frame from the actual event to the notification of the engineer needs to be automated. There needs to be a way to answer the business questions that aren't typically answered by the protection engineer by just analyzing the information in a COMTRADE file. And these are asset-oriented questions for condition-based maintenance and preventive maintenance purposes. Were there any high-value assets impacted, like power transformers? How many events has this particular asset actually encountered? If there are several events of a similar nature for a particular asset, that may be an indication that some type of electrical system design change may be needed. What customers were impacted, and is this a recurring pattern? Additionally, since most operations in a utility is based upon EMS SCADA, and those SCADA systems don't capture this information, there's no true view of the system operation because the SCADA information doesn't contain the disturbance information. The SISCO COMTRADE utility actually provides a solution for all of these issues. How does it do it? Well, the utility actually counts on the proper configuration of triggers to capture the COMTRADE disturbance event in the devices. So the disturbance detection and the capture is actually done in the devices in the field. The COMTRADE utility actually is then configured to go and look at these devices automatically on a scheduled basis to determine if there have been new configuration or disturbance files created. If there are new files, the utility generates the potential to use PI notifications to actually generate automatic notifications that there are new events. It automatically decomposes the information in the COMTRADE utility into PI tags, and if properly configured, can associate those events to assets that are maintained in AF. There are some use cases that actually require export of this information, which we'll talk about later. The original files are also archived within the PI system, and there's a mechanism provided by the utility to actually retrieve those files and actually automatically invoke the COMTRADE viewers that a protection engineer might want to use, thereby creating a centralized repository whose maintenance and backup is actually part of the overall PI system maintenance and backup procedures. The utility actually can retrieve files based upon FTP, IEC 61850 file transfer services, or access to a local hard drive. It supports the native COMTRADE format. Some customers desire to zip their COMTRADE files, so that is supported as well, and a file format for power quality, which is called PQDIF. It's another IEEE standard. When the COMTRADE utility detects and processes a disturbance file, it does two things besides decomposing and putting the data into PI tags. It creates an event frame where the actual raw file is stored, and it creates the ability to trigger PI notifications. When you trigger a PI notification, the information can be delivered via email, web services, or what are called custom delivery channels. The event frame can then be used additionally to display the data in PI Process Book or PI Coresight or other visualization mechanisms. The one true view is shown here where the SCADA data is integrated with the disturbance data. What we're doing right now is we're zooming in on the disturbance data, and you can see it's at a much higher sample rate than the 2 to 5 second SCADA point, which was the normal sinusoid that you saw on the display. Here's what a COMTRADE event looks like in Coresight. Again, it's very high fidelity information sampled at 20,000 samples per second. This display actually consists of about 60 equivalent channels of information consisting of both digital and analog information. As was told before, the COMTRADE utility actually stores the raw COMTRADE files as an attribute in the event frame. There's a special attribute called file. If you want to save and use the raw files, the special extension SISCO actually represents a zip file. So you can save it as a zip file and then open it normally. Or if you configure the utility can open the file and actually invoke a specialized COMTRADE viewer, which protection engineers typically use. In order to correlate the transient events to assets, obviously that relationship needs to be pre-configured in the COMTRADE utility. But it allows you to go to the asset, TA1 is a power transformer here, and see the actual event frames generated by the COMTRADE utility that could have impacted that particular asset. This allows for a condition-based maintenance or asset-oriented analysis of the disturbances that could allow businesses to actually determine they need to go out and do maintenance earlier than anticipated. There's a use case in the United States for synchrophasers where the synchrophaser information is actually captured and archived. However, past history of the synchrophaser information needs to be exchanged to other utilities. The COMTRADE file format has been selected by several coordination councils to be used for this purpose. The COMTRADE utility actually allows the export of synchrophaser information, which are held in PyTags, and other PyTag information into a COMTRADE file format. This file can then be used for exchange to other utilities, or in some cases, test tools can actually be used to play this information back in real time. In summary, the COMTRADE utility allows one true view of the system to be created. It creates automation and efficiency in locating and notification of disturbances. It creates the centralized repository for the disturbance files so that protection engineers can go back at any time and actually analyze the files that could have occurred years prior. And it allows for the configuration and correlation of these disturbances with the assets that could have been affected and therefore have a role in the preventive maintenance and condition-based maintenance cycles. Thank you for your time. If you have any additional questions, please feel free to contact any of us at SISCO.